So last chapter, we covered independent groups design, which focuses on experiments in which we have different people in our different experimental groups. However, that is not always the case. So in repeated measures designs, we have different levels. We have an independent variable and a dependent variable, and we have different levels of our independent variable. But instead of having different people in each group, we actually have the same people do the experiment twice or more. And so the same people participate in each level of the independent variable. Okay, so this is sometimes called a within persons design because the subject serves as their own control group. Okay, so maybe they fill out measures of anxiety during a closed book test, which is the control condition, and then they also fill out measures of anxiety during an open book test, which would be the experimental condition. So this is called repeated measures because the participant completes the dependent variable in both conditions. And so again, this is in contrast to the independent groups where you have different people doing each condition. So in the example I stated previously, you have one group that completes anxiety during an anxiety measure while they're taking a closed book test, and a different group that completes a measure of anxiety during an open book test. And the big thing that we deal with in repeated measures is counterbalancing. So the big potential issue here is that participants get practice doing the experiment, right? Because they do it more than once. And so you have to think about how you're going to manage that. And the strategies you use to manage that differ depending on how you structure the experiment. And one of the big kind of distinctions is how many times each level of the independent variable is given to each participant. So in an incomplete design, they are given each level of the independent variable only once. Okay, and so the strategies you use for an incomplete design differ depending on how many conditions there may be. In contrast, in some experiments, the experiment may be really, really short or easy to do. And so we might actually have each participant complete each level many times. This is called a complete repeated measures design. And so here with complete repeated measures design, you can actually balance practice effects for each participant because each person is in each condition multiple times. Okay, so for complete repeated measures, every participant does each condition or each level of the independent variable multiple times. Okay, so we are balancing practice effects within each participant. So each participant experiences each condition several times, and what we do is we differ the order each time. So the thought is that their responses are going to change with repeated testing. So it could change in a couple of different ways, right? Their responses could get better. If you're measuring something like reaction time, they might get quicker as they get more practice. In contrast, their responses could also get worse. So if you're asking them to fill out a questionnaire or something, they could get bored and stop focusing. So when you have a complete repeated measures design where everyone's doing each level many times, there's two methods for generating the order of conditions. So almost all of what we're talking about in this chapter is how do you figure out what order you present the conditions, the different levels of the independent variable in. The first one is block randomization. Okay, so here the order of the conditions for each participant in a complete design. The example I'll use is the one that your textbook uses where you're showing people pictures of, actually, no, I won't use that example. Let's use the example from the textbook is that you're showing people pictures of an emotional face. You're showing them either the left side of the face mirrored, the right side of the face mirrored, or the original, and asking them to rate something. And so it's a very quick trial, and each time they show them the left side, the right side, or the original face, and have them rate on a very quick scale. Okay, and so each rating is a different trial. And the different versions, the different faces they see would be the different conditions. And so with block randomization, what you're going to do is you're going to list your conditions of the independent variable, and then generate a random order of trials within a block. Okay, so a block is one of each of your conditions. So if you only had 3 conditions, a block would just be those 3. And then you're going to organize them in a random order. And every single block the person gets, so maybe the person, we have people do 8 blocks of your experiment, which means they do 8 versions of every level. But each block that they do is going to be in a different order. Okay, so in a block randomization, you need to assign each condition a number. So if we're doing left side of the face, right side of the face, and original face, maybe left is 1, right is 2, and original is 3. Doesn't matter, because the goal of this is to get a random order. So this sounds complicated, but try to keep in the back of your mind that the goal is just to get the conditions in a random order. Table A1 of your textbook has a list of random numbers. It's exactly what it sounds like. They're random. So it doesn't matter which row you start on. You're just going to pick a row and go through. And in this case, we've got 3 conditions, 1, 2, 3. We want to see what order they come in first. Okay, so we only want one instance of each of those numbers. So if we have multiple, we're going to ignore them. But I want to figure out what order to present 3 conditions in. Here's a 2, so I present the 2 first, and then there's a 1, so I present the 1 first. We could keep going and ignore all the others, or we could just say we know 3 is going to be the third one. Okay. So that's one strategy. And then every time you do a new block, you go to a different line and you find a different order. Another strategy is using what's called ABBA counterbalancing. So you can balance practice effects with as few as 2 trials in each condition. And here you present the conditions in one random sequence and then do the opposite of that. Okay, so you've got one random sequence that you go through the same process for, and then just flip it for this one. Instead of doing completely random for the second block, you reverse the first block. So ABBA only works if the practice effects are linear. So linear practice effects are when participants change the same way with each presentation of the condition. So they get a little bit better every single time, slow and steady improvement or decline. With nonlinear practice effects, this is when people have like an aha moment after their first trial. So this will be when participants change dramatically with the administration of a condition. If you've got something with nonlinear practice effects, you really need to use block randomization and a lot of trials to get rid of those practice effects. Okay, so this is what linear practice effects look like. Okay, so if you have linear practice effects, then this is the left original right example that I showed you. They get 1 point better in the second trial, 2 points better in the third, 3 points better. So you can see they're getting gradually better each trial. They're getting maybe faster or something like that. In contrast, if the practice effects were non-linear, you don't see any effect here, but they get to trial 2 and all of a sudden they get what you're asking them to do. And now they're improving by the same, they've got it, they're faster, and they stay at the same speed the rest of the time. Okay, so if you have linear practice effects, ABBA can work for you. If you have nonlinear practice effects, you really need to do the block randomization. And again, this is for complete design. So this is, in this case, everyone is doing each condition 2 times, but you could have them do it even more. Okay, next, for an incomplete design, each participant experiences each condition once. So if they get the control condition first, the experimental condition could be better because of the independent variable, or it could be because of practice effects. So here, you don't know what is causing it, and you're not balancing it within your participants, so you have to balance it across participants, okay? And so here, One strategy is all possible orders. So this is every possible combination of orders. This is the ideal situation. So for example, if you have two conditions, then you have two possible orders of the conditions, right? People get A first and then B first, or people get B first and then A first. You randomly assign half of the participants to do condition A first and half of the participants to do condition B first. Maybe you have 20 people doing A, then B, and 20 people doing B, then A, and you've got it balanced. If you have three conditions, you get 6 possible orders. Okay, so you need to divide your participants up among those 6 possible orders. If you have 4 conditions, you have 24 possible orders. So this gets really big really fast. So you need to have at least as many participants as you have orders. And so if you have very few conditions, then this can potentially work for you. If you have a lot of conditions, then you might need to use what's called a Latin square. For a Latin square, each condition appears in each ordinal position once to affect balance to balance practice effects. Okay, so this is with 4 conditions, and this is the order. Obviously, the conditions are A, B, C, D, and this is when A comes first, second, third, and fourth. Now, I'm not going to ask you to redesign a Latin square. What I'm going to ask you to do is say, here's an experiment that has 4 different conditions. Tell me which condition is A, B, C, and D, and tell me what order they should be presented in. So right now I'm just kind of explaining how the Latin square is designed. And again, you won't have to design it. You'll just need to apply it to a given experiment. So the first key is that each condition appears in each ordinal position once. A is first, second, third, and fourth. Another component of this Latin square is that each condition precedes and follows every other condition once. We have D, then C, we have C, then D. A, then D, D, then A. E, then C, C, then B. This helps control for potential order effects that might be kind of specifically related to one condition influencing another. So Latin square is a really good option. Another potential good option is what's called random starting order with rotation. So here you generate a random order of the conditions. In this case, we randomly decided to put them in A, B, C, D. And then you rotate or you move in each condition in one position. So the first person, and because this is incomplete designs, everyone gets each condition once. So each row would be 1 participant. So the first participant would get A, then B, then C, then D. Then they get shifted. Your second participant gets B, then C, then D, then A. The third participant would get C, then D, then A, then B. And so here you have each condition appears in each ordinal position. A is first, second, third, and fourth. But the order of conditions is not balanced because A almost always happens after D. Okay, so this is maybe not ideal because there could be some specific effects. So these are kind of your options. And again, kind of the big things to think about are how do you, is it a complete design where everyone does the conditions multiple times, or is it an incomplete design where people are only doing each condition once? And that'll determine the options that you have in terms of assigning conditions. So for these repeated measures stuff, the big thing here is figuring out what order people are going to do the conditions of the experiment in. And that's the big kind of challenge of this chapter.